the other topic that I thought you had trouble with was like floating point binary, basically. So that's question 2. The first 2 should be pretty straightforward. Most people got that right. You've just got to take a binary number and work out on the number line. Like, so, what was it? Question 2, A, I, 1, right? You've got 2, 3, 1 on the binary, on the number line. You've got to work out what that is in binary. So you've got 8 bits. You'd put a 1 in the 128 column, a 1 in the 64, a 1 in the 32, and then 0, 0, a 1 in the 4, a 1 in the 2, a 1 in the 1. So you'd get that. You can also use that method where you divide it by 2. Does anyone remember that one? Where you divide it by 2 and you look at the quotient. It's a quotient rule. Yeah. But and then the hex one, which is the second one, you've got 6f. It's very simple. Just split it up, right? Just split that up into 2 binary digits. The first one is 6, 0, 1, 1, 0, and then 1, 1, 1, right? So hopefully everyone's got that okay. So converting between the bases and figuring out binary numbers should be pretty straightforward. But this one, a lot of people got stuck on. So what is the floating point number 0, 0, 1, 1, 0, 1 with the exponent 0, 1, 1, 0, 1, 0, 0. So that's the mantissa, 6 bits, and then you've got 4 bits for the exponent, right? They're both in 2's complement, so that means that you need the leading, the most significant bit, if it's in a positive binary number, should remain at 0. Yeah. So I think some people, what they tried to do is they multiplied it out, but they ended up putting like a 1 on the end or something. So basically, this is not a normalized number. So B1. I can tell that's not normalized. So 0, 1, 1, 0, 0, 1, 1, 0, 1. Yep, and then that's the exponent, and that's the mantissa. I can tell that's not normalized because I've got 2 leading zeros or 2 leading 1s. So imagine the point is there. To normalize it, I've got to shift it the decimal point 1 place to the right here, and then you pad it with zeros because you've got to keep it at 6 bits, right? So if I'm moving it 1 place to the right, that means that to get it back in its original form, I'll have to move it 1 place to the left. So when you move the point to the left, you take 1 off. It's like a negative direction. So you have to take 1 off this exponent. So what would this exponent be if I take 1 off it? So this exponent is currently what number? Yeah, it's 4. So if I take 1 off it, it's 3. And 4, and so sorry, minus 1. I take 1 off it, it's 3. So that equals what? What's binary for 3? What's that? What's binary for 3? 0, 0, 1, 1. Right, okay, thanks. Yeah, so that's the new exponent, and then this is the number in normalized form. And you don't have to include the bit, because in floating point, you just assume that point is between the first leading 1 and the 0, or 0 and the 1. if it's normalised. So that's fairly straightforward. Yeah, you just got to shift the point and then add one or take one off the exponent. Um, so if you didn't get that right, make sure you write that down and understand that. Yeah, and also like go and do the practice exercises that are here on this worksheet on Medium that I've linked to. There's tons of exercises you can work through, and there's past paper questions at the end with there's some practice exercises here right at the end, and then past paper questions. Then the next bit was part 2. So it says you've got to now convert this number to denary, right? So how would I do that? What am I going to do with this? What's that going to become? What am I going to do with the decimal point? Think about that. The point's here, and I've got to multiply this number out. So it's like if you had like 9 times 10 to the power of 12, or not, okay, 9 times 10 to the power of 6, and I multiplied it out, like you're just having to do the same kind of thing, not in denary but in binary. So you're multiplying your mantissa by your exponent. So what is this exponent telling me to do? That question goes to anyone who wants to shout it out. Like Harry. So what is that exponent? What is the value? 3. So that will shift the best decimal point in which direction? Left or right? Why left? Why do you think left? So if you're going to move left, it must be negative. If it's positive, you move the decimal point right because you're making the number bigger. Yeah. So a negative exponent makes a number smaller. Like if you did like 9 times 10 to the power of minus 6, then you might going to have a much smaller number, up like 6 zeros after the decimal point or something. Yeah. But if we multiply by a positive exponent, it's going to make it bigger. So we're shifting it to the right. So I'm going to shift that decimal point 1, 2, 3 here. Yeah. So that is our number. And what is that number in decimal? Yeah, 6. And then after the point in binary, you just divide you divide the number by a half. So half of 1 is a half, then that'd be a quarter, an eighth, and so on. But this is just a half, so we've got 6.5, right? So that should be an easy 3 marks, really, once you've normalized the number. And I think maybe if you made a mistake in your first one, they would be carry 3 marks as long as you were consistent. So, like if you knew how to multiply a floating point number out using the exponent, but you made a mistake calculating or normalizing the number in the first part, you'll probably get some marks for showing your working. So don't just leave it out. Yeah, the next one, possibly a bit more tricky. You need add together 2 numbers below, right? Both numbers are stored in normalized floating point format using 6 bits for their mantissa and 4 bits for their exponent, which are both in 2's complement. Show the result in the same format and show your working. So, like what we've just done before, you're going to have to multiply these numbers out using the exponent, and then you're going to add them, right? So the first one is this one. So make sure you're writing this down on your paper if you didn't know how to do it, yeah? So, Brandon, what's that exponent? 6. So the decimal point is always between the leading 1 and the 0, 0 and the 1. It's here. So where am I going to shift the decimal point? Right or left? Yeah. So we're going to go 1, 1, 2, 3, 4, 5. And we have to pad it with 0, 6. So even though it said use 6 bits of the mantissa, that's only when it's in normalised form. Yeah. You don't have to truncate it once you've multiplied it out, right? We need the whole number. Yeah. So we've got our first number. What's this one then, Zion? What's that exponent? What's the value of it? So is that, I've been looking at this, so is that just a normal number, or is that? This is a binary number. Okay. What value is it in decimal? 4. Is it 4, Daniel? Oh. What value is that? So the first column's for us 1, 2. Oh yeah, it's 4. Sorry. Yeah. Right. So which way, George, are we going to shove the decimal point? Right or left? Right or left? Right. Okay. So we go 4 to the right. 1, 2, 3, 4. Right. So we need to add. So I'm going to pad this with zeros, so it's got the same number of digits. We need to add these two together, don't we? So, can someone do this addition? What's 0 plus 0 in binary? Okay, thanks. What's, and 0 again, and then what's 0 plus 1? 1, 0, 1, 1, 1, 0. So that is our answer. But they have said show the result in the same format and show your working, right? So how would I go about normalizing this number that we've just added up, Jacob? What have I got to do to the? Just look at it on the board. What have I got to do to that decimal point? Where have I got to move it to normalize it?
To the right.
Yeah, well, we want to get that point between the leading 1 and the 0, right? So how many places are I going to have to move the point?
Over by 1, 2, 3, 4, 6.
6 points, 6 places, right? So what would our exponent be? If I've shifted it 6 to the left, then what have we got to multiply out to get it back into its original form? By the way, we can only have 6 for the mantissa. So 1, 2, 3, 4, 5, 6. So we're going to delete those 2 zeros. So we're going to multiply it by, which in binary is
0, 1, 1, 0.
0, 1, 1, 0. So that's your answer, right? To this addition of these two numbers. So you've got to multiply them out first, add them up, and then you've got to normalize it. You've got to shift that decimal point back to when it's between the leading 1 and the 0, 0 and the 1, right? Yeah? Does that seem pretty straightforward now? Because a lot of people didn't get that. Yeah. So to practice, go and have a look at this link that I've linked on the post below. Then have a look at some of the practice questions here. Like, so multiply practice 1 is convert these normalized binary into denary, normalize the following, and then convert. These are quite difficult. These are about the hardest things you'll get. So give those a go. Yeah.